he's up on the thing here. He has a roughly a baseball sized piece here. And boom.
Need some.
Now, what happens many times is it'll actually blow itself out of the water, come back down, land in the water, do that again, jump out of the water, go someplace else, do that again. And so there's like an ultimate form of skipping rocks type of thing here.
So high up in the air.
That's there, there's another piece over there. But look what happens when they pan up.
Why didn't they show the other piece?
He probably missed it. Okay. Not that one.
That was sweet. I didn't expect it to go that high.
Now, this other one, I'm not gonna show you the whole video here. It's a British TV show. And this is showing what happens when you put the other two elements, rubidium and cesium into water.
They're probably a lot bigger.
Yeah. Yeah.
Rubidium's under potassium.
The cesium's under rubidium.
And watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad.
Now, 2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes! That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There's one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty to go off at any time.
And that's it.
Oh, yes.
I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John, go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, frankium. But for some reason, they wouldn't let us have any of that. So there you go. Today's lesson.
Never mixed alkali metals with water.
Now, the thing is, if you ever see videos, if you type in like francium in water here, there is not enough francium in the water to make an explosion that even that big. You would have to mine most of the Earth's crust in order to get just a few grams of francium. And there, with that rare amount, you're not going, won't have anyone able to buy that stuff here for that purpose. Now, I had one year where a student, I can't find the video, but this was like a picture, yeah. This is the picture they showed me. He was like, oh, this is, you know, francium in water. Now, this was a photograph of when they're testing a nuclear bomb in the water. Okay. That's not, you know, and if you look up here, it'll say francium reaction with water. First of all, one, it will not be that big. And number two, there isn't enough francium to make that an explosion that big. So, if you see anything like that, it's not real. Alright, tomorrow, bring your colored pencils, if you have any.